Following World War II, the American landscape was dotted with rows of conventional fighter jets, machines that represented the height of piston-powered engineering. However, as the Cold War began to crystallize, these vast fleets faced a set of tactical problems that their airframes were never designed to solve. The emergence of supersonic bombers meant that conventional interceptors could no longer launch and climb fast enough to protect high-value targets. This created an urgent need for point defense interceptors, specialized machines capable of reaching high Mach numbers almost instantly. But the straight-wing designs that dominated the 1940s hit a hard physical limit. At high speeds, the air resistance against these wings created massive structural stress, making supersonic flight effectively impossible with existing technology. To bridge this gap, engineers abandoned the known laws of physics. They turned away from proven designs and entered an era of radical, unproven ambition. The government directed massive investments toward borderline science fiction aviation concepts, hoping that extreme shapes and experimental engines could overcome the barrier of drag. This rapid push into the unknown produced a collection of ghosts, multi-million-dollar aircraft that were either too dangerous to fly or too advanced for the technology of the day to support. By examining these spectacular failures, we can see the brutal, hidden costs that were required to eventually achieve modern air supremacy. America's first radical attempt to shatter the interceptor barrier was the Convair XF-92. The aircraft was designed to address the primary enemy of supersonic flight, drag. At high speeds, air piles up against straight wings like a dense wall, requiring massive energy to push through. The XF-92 replaced those wings with a sharp, triangular delta wing. The theory was that this swept-back geometry would allow the aircraft to matrix the air, letting the resistance lay smoothly around the fuselage instead of piling up in front of it. On a purely theoretical level, the XF-92 was an aerodynamic masterpiece, seemingly destined for effortless supersonic flight. However, the physical reality of 1940s hardware could not keep pace with the brilliance of the airframe design. At its core, the aircraft relied on an Allison J-33 turbojet engine. The delta wing design required immense forward thrust to stay stable and efficient, but the J-33 was a primitive engine that struggled to produce the power needed for such a radical shape. This mismatch between a futuristic wing and a weak engine effectively turned the prototype into a dangerous, unpredictable experiment. The underpowered engine meant the XF-92 could rarely reach supersonic speeds on its own. Test pilots often had to force the plane into a steep, high-risk dive just to break the sound barrier. Pilots described the aircraft as nearly uncontrollable. At lower speeds, the delta wing lost its aerodynamic efficiency, forcing pilots to wrestle a wild animal just to keep it in the air. Every approach and landing became a gamble, as the benefits of the swept-back design vanished during the slower speeds required to reach the tarmac. In 1953, the luck of the project ran out. A violent landing caused the landing gear to collapse, causing structural damage that the program could not recover from. The XF-92 was permanently grounded, a ghost of the Cold War era that had been defeated by the gap between vision and available technology. Despite its failure, the question remains, was the expense and the danger of the XF-92 a waste of resources? The data gathered from those unstable test flights was irreplaceable. It provided real-world aerodynamic insights into the delta wing that no wind tunnel could have predicted. That data led directly to the F-102 Delta Dagger. This aircraft used the same triangular wing profile, but paired it with more sophisticated engines and refined aerodynamics that finally solved the stability problems of its predecessor. With the lessons of the ghost planes applied, pilots were finally able to operate these high-speed machines with confidence and precision. The success of the Delta Dagger, which served as a backbone of air defense for years, was built entirely on the raw data harvested from the wreckage of the XF-92. This was the standard operating procedure for the Cold War race for air supremacy. The lethal risks and catastrophic financial losses of these programs were a calculated byproduct of the arms race. These failures represented the necessary friction created when engineers attempted to force the future into existence before the technology was ready. Perfection at the bleeding edge of physics requires a toll. Every sleek, modern fighter flying today is a dividend paid by those early, spectacular failures. Without the terrifying sacrifices and technical gambles of these early ghost aircraft, the era of modern air supremacy simply would not exist.